Hi and welcome back. This is helpmegraduate.com. Hector here. We're going to be talking about derivatives of exponents, okay? So let's say we have a function f of x with this appearance, okay? K x power to n. And k and n, for now we're just going to say that they belong to the set of the rational numbers, okay? That means that they can be integers or fractions, okay? We're going to deal a little bit more in deep with that subject in an upcoming video called chain rule, but for now we're going to stick to that formula, okay? Let's say we have a function with this appearance, okay? We have a constant multiplying an x, and that x is powered to a certain exponent, okay? Let's say kxn. The rule to find the derivative for that, and you can see that demonstration in another video that I'm doing regarding demonstration of properties of derivatives, is going to be the following. So if they are asking me for fx prime, the procedure is k, the n of the exponent goes down multiplying x, and I decrease in 1 the degree of the exponent. Okay? And it's as simple as that. F prime, or the derivative function of something that looks like kx power to n, is going to be k multiplied by n, multiplying x the variable, and the degree and the exponent is decreased by 1 degree. Okay? It's just as simple as that. And remember, the exponent n is a rational number, so that's going to be really helpful when we're dealing with something like a fractional exponent. We're going to get to that in a second. Let's do a couple of examples following the rule, okay? I'm going to do them. Let's do them here side by side. First example, let's do something like f of x equals 3x power to 4. Okay? It's just exactly the same format that we have right here, as you can see. We have a constant k, which in this case is 3. We have the variable, and the degree of the variable is 4 in this case. N equals 4. So how do we do that? Well, let's do it very slowly, and then we'll pick up the pace in the following examples. Okay? F prime, they're asking me to find f prime of x is going to be 3 stays the same, k stays the same. 4 goes down. 4 goes down, the degree of the exponent goes down multiplying k. Okay? X. And now I subtract 1 from the degree of the exponent. So 4 minus 1 is 3. And there you go. Of course, I have to multiply this to simplify it and make it look better. In essence, f prime of x will end up looking like 3 times 4, 12, x cubed. And there you go. That is the answer for the first example. It's just as easy as it is. Okay? All you have to do is keep practicing, and you will do fine. Let's do another example, a little bit more trickier. But don't worry, won't be anything to be afraid of. Second example. Let's suppose we have something like fx, and let's say we have something like something interesting, minus 8x minus 2. Okay? We have f of x minus 8x powered to minus 2. Let's write the 8 a little bit bigger. I think I did a little bit small. Whoa! What do we do there? We have a negative exponent. That's better. What do we do there? We have a negative exponent. Oh, that's scary. What do we do? Hey, remember the rule. K, x powered to n, and k and n are rational numbers, so it doesn't matter if it's positive or negative. The rule says exactly the same, and all I have to do is be ecstatic that the rule exists so that you can apply derivative of exponent functions. Okay? So let's say they're asking me to find f prime of x, and this is going to be nothing else but minus 8 multiplying, guess what? Let's do the parenthesis to be organized. The degree of the exponent goes down, multiplying minus 2 times x. The degree of the exponent is decreased by 1. So, minus 2 minus 1, because the rule, okay, n minus 1, and an n in this case is minus 2. So minus 2 minus 1 is minus 3. There you go. That's it. All we have to do next is simplify. F prime of x equals minus times minus is positive. 8 times 2, or 2 times 8 is 16. 16x powered to minus 3. And there you go. That is the solution for the exercise. You see, there's nothing to be afraid of if the exponent is negative. If the constant k is negative, there's nothing to be afraid of. The rule remains exactly the same. Okay? Let's make a third example. Of course, let me erase this so that we can have a little bit more room. And this example is going to feature something a little bit more tricky, okay? I will go more deep into it in another video because it's going to deal with irrational exponents. But for now, I'm going to try to keep it simple, okay? Let's say we have something like f of x equals, let's say we have 1/5 of x powered to minus 1/3. Okay? F of x is 1/5 of x powered to minus 1/3. Whoa! What do we do now? We have fraction in k, fraction in the constant variable, fraction in the exponent. How do we do, what do we, relax, don't worry, everything is under control, okay? Just follow the rule. The rule states that k and n can be rational numbers. This is a rational number, this is a rational number. So all we have to do is follow the rule, and we will be fine, okay? Just be organized and remember to add properly fractions, okay? So, f prime, which is what they're asking me for, is 1/5 multiplied by 1/3 minus 1/3 goes down, the exponent goes down, minus 1/3 x minus 1/3 minus 1 because of the rule, okay? Minus 1/3 minus 1 to decrease the degree of the exponent in 1. So minus 1/3 minus 1 is minus 1/3 minus 3/3, right? So that is 4/3 minus 4/3. And there you go. This is it. What's up next? Simplify and we will be fine. Okay? We can do it right here at the bottom. F prime, let's do a little bit more to the left. This implies that f prime of x equals minus 1/3 times minus 1/5 is, minus stays the same, 1 over 5 times 3 is 15 x powered to minus 4/3. And that's it. That is the solution for the exercise, okay? The fact that we have a fraction, a rational number in the constant k, or in the exponent, doesn't affect the rule at all, okay? There's a little bit of a slight detail that I'm going to be mentioning in the video of chain rules for rational functions and radical functions, but don't worry, you can just watch that series and you will get the grip of what I'm saying, okay? Keep in mind the following, okay? The fact that we have rational exponents or negative exponents is just a rearrangement of mathematical expressions, okay? In another video I have mentioned this, but I'm going to repeat it again just for sake of education, okay? When we have something that says, for instance, let's pick the original example. When we have something that says x powered to 1 cube, x powered to 1 cube, this is exactly the same as saying the cubic root of x. Okay? It's just rearranging the expression in form of an exponent, the exact same thing. When we have something that says x powered to the fraction of 1/2, that is the exact same reasoning of saying square root of x. Okay? The denominator in the function is the degree of the square root. Okay? And the numerator of the fraction is the degree of the x inside the root. Okay? When we have something that says x powered to -5, for instance, it's exactly the same as if I was saying 1 over x powered to 5. The negative number, all that it's saying is that in reality the x is a denominator of the function. Okay? So let's say if we have something like x powered to minus 1/3, sorry. That means that we have 1 over the cubic root of x. Okay? The negative means that in reality the variable is on the bottom side of the fraction, and the cube, the 3, and the denominator of the exponent means the degree of the square root. Okay? It's just a couple of rearrangements of functions. Okay? And you can see this in any textbook. Okay? So, I hope you understand this part. Everything is okay. We will now in the next video do more examples of derivatives of exponents.